about the unit circle and a way of understanding how trig functions work, sine, cos and tan, by using the unit circle. So we set up the idea of a unit circle is a circle, and we put it on a set of coordinate axes to help us locate things, and it's got a radius of 1. That's why it's called the unit circle. It's a radius of 1 unit. And so it crosses the axes at 1 up here, and a -1 down here, a -1 and 1. That's what it is. And I'm just going to drag this around here. So we can set up different points on that unit circle. And so I've chosen a point here. There it is. The point up there on the unit circle. And it can be described in two ways. We can talk about it in its x-y coordinates. That's a normal way that we do it. But we can also talk about the angle through which we've rotated from the x-axis in a anti-clockwise direction. And so this point here has been arrived at by rotating through an angle of 30 degrees. I've got 30.07 there, that's as close as I can get. 30 degrees up on the, from the x-axis up to that point. Now, we can also then describe a right-angled triangle that has come from the selection of that point. It's this right-angled triangle here. I'm just going to draw it over the top to kind of help us focus on that. That's a right-angled triangle. This here is a right angle. It has a hypotenuse of 1, and it's got these two other sides here. Now, from our interactive, it actually tells us kind of the length of each of those sides. But we can describe that in a different way by saying that sine of 30 degrees equals the x-coordinate, sorry, not the x-coordinate, the y-coordinate. The y-coordinate here over the hypotenuse. And why do I pick the y-coordinate? Because the y-coordinate tells us the actual the height above, or the distance above the x-axis. It tells us the length of that side, doesn't it? The y-coordinate says this is how far that point is above the x-axis, which is the same as how long that side of that right-angled triangle is. We're okay with that? Okay, so it's 1 over, so y over 1. And therefore, because it's y over 1, it's actually just the same sine 30 equals 30 degrees equals y. And that's how we know that that side is 0.5 in length, because sine of 30 is 0.5. But it also tells us something else. It tells us that this y-coordinate here is exactly the same as the sine of 30 degrees. The y-coordinate here is exactly the same as the sine of 30 degrees. Now, is there another place on that unit circle that has exactly the same y-coordinate?
Yes.
Yeah, it's over here, isn't it? It's this point over here. That y-coordinate over here is exactly the same as this y-coordinate over here. That's the sine value of the angle that gets us to that point is exactly the same as the sine value of the angle that gets us to that point. And what is the sine? What is the angle that gets us to that point? Well, it's the angle that we've got to rotate through to come all the way around here. Let's do it on our interactive. So if I drag this one right around, and it takes us all the way over to this side to that same point there. Okay, there we are now. Another point on that unit circle with the same y value, and therefore another point that is equal to sine of 30 degrees. But what is the angle that we've gone through? What does it say? 150. So sine of 30 degrees is equal to that y value, but sine of 150 degrees is also equal to that y value. What does that mean? These two values here must be exactly the same. Sine of 130 and sine of 30 and sine of 150 must be exactly the same. And that's why we talked about the fact that if you have sine of any angle, it is equal to sine of 180 minus that angle, if we're talking in degrees. Okay? if we're talking in radians, sine of any angle is equal to the same as sine of pi minus that angle. Okay, that is a relationship that is true no matter what. And we kind of see it from, or we can look at it another way, I should say, from this one over here. This here is, well, I've chosen the wrong one. Sorry, let's pick it up. And I just want to zoom in a little bit on this. Okay, so what we've got here is a sine graph. A sine graph here, and we can see that there is a place here where sine, let's just pick this value here, for example. And there's another place over here that has the sine of that, and another place over here that has the same, so y value, another place here the same y value, and all the way along. In fact, we even go back this way too. This has got the same y value over here, and it's got it over there. Can we see that there are actually infinite number of places where the sine of an angle will equal whatever that is, about 0.8, I think it is on the thing there. I'm going to grab that one, is there someone at the door?
I think so.
So there are actually any number of places, infinite number of places. And it's because when we go back to our unit circle, here, well, there was that y value over here, the same y value over here, but we can keep going. Past 360 into another 30 degrees. So sine of 390 would give us the same value. Sine of 510. Keep going. Sine of 750. Sine of 870 would keep going. And we keep getting the same y values. Trig functions are called wave functions. They keep coming back and forth through that same range between 1 and -1, and there are infinite number of angles that will give us that same y value. We can talk about the same thing when it comes to the cosine of an angle. Alright, so there we have an angle of 36.7 degrees thereabouts, that we've rotated from the x-axis up to that point, and that has given us an x value of that point of 0.8. And in the same way, we can talk about the cosine of 36.74 degrees equals 0.8 over 1, well, just equals 0.8. But there is another place where the cosine equals 0.8. Where would that be? Also, where the x value equals 0.8. Where's the other place?
The reverse.
Yeah, down here, isn't it? Down here somewhere. That's the other place on this circle, around about there, where the x value again equals 0.8, and where if we went through the same process, we'd find another angle with a cosine value of 0.8. What is that? Let's drag this point around. What do we get to? Okay, so here we go, 323.24. If I wanted to just count a little bit around, there we go, 323.26. And we find that 323.26 also gives a cos of 0.8. Okay? The cos of 323.26 is also 0.8. Once again, we can say that these two values are exactly the same. The cosine of that angle and the cosine of that angle are both exactly the same. And so we came up with I guess a rule for that is that cos of any angle is equal to cos of 360 degrees minus that angle, or in radians, cos of pi equals cos of theta equals cos of 2 pi minus theta. So we come up with those I guess rules or formula that we can use. And it comes from our understanding of this unit circle. That because of the nature of the unit circle, there are always two places with any particular x value, or two places with any particular y value, except for the extremities, of course. There's only one place that's got an x value of 1 or -1, but everywhere else there's two values. And we can get an understanding of how cosine and sine, and then tan as well, they relate to each other. Okay, the different angles, sine at different angles, or different sine, cosine at different angles, they relate to each other.